All right, this is a weekly update from Mr. Fix's science class for the week of March 11th. All right, so every day we do magnetic fields review. Well, most days we do. So this is basically questions based on the content from the last lesson the day before. So you can see it marks, hey, this is a question from lesson 1.3. And so it includes key concepts, includes vocabulary terms, and includes usually some pictures and some animations on the concepts. So again, this is lesson 1.5. On Monday, we did Amplify magnetic fields to 1.2 to 1.3. So basically, this was a kind of a review of the first couple of lessons in magnetic fields. So students were given some vocabulary words, some key concepts, and basically it was questions basically from the review to see their understanding of those concepts. Again, students can retake, that's what the homework is to redo any assignment for higher score. They can notify me via email that they're doing this. For an Edpuzzle, they can ask me to, hey, can you reset my Edpuzzle so that I can do it again for a higher score, and I do that. I always do that for them. Then we did magnetic fields lesson 1.4, Earth's geomagnetism, where they read, the main point of the lesson was reading an article about Earth's geomagnetism. All right, so this is the article on Earth's geomagnetism, where students had to annotate key concepts, some interesting ideas, some words they might not know, and it's all about Earth's magnetic field, kind of how it is, what it is, how it works, how it can be useful. So we did that. And then on lesson 1.5 on Tuesday, it was all about investigating magnetic field lines, including some exploring and modeling. So students had to use the Amplify sim, where they had to place two magnets nearby each other. They had to toggle on the magnetic field lines and see how they're arranged. And so this is what the magnetic field line look like when the like poles, we have north-north and south-south, face each other. They can also switch it so that the opposites are facing each other. So this is south-north and south-north, and see how the magnetic field lines are arranged. They can also see how when they're kind of misaligned, what kind of happens with them as well. So kind of interesting things happen when they're kind of not totally lined up together in a straight line or parallel to each other. So they took a look at that. Then we did 1.6 on Wednesday. They did some more analyzing field lines, and let's take a look at the slide deck on this one. All right, so they completed a warm-up. This is a warm-up based on the previous day's lesson. They had to fill out this modeling tool, this actually predicting motion modeling tool. We got some information about the launch of the spacecraft, the testing of the spacecraft system. That Monday's launch was 80 meters per second after launch. Tuesday's was increased by 90 meters per second. This is the distance between the magnets, and with 1 centimeter closer on Wednesday, it was a 30 meter per second increase. So it was much faster launch speed on Wednesday than Tuesday. So we're kind of trying to, well, what's going on there? There was a claim that the magnets were misaligned on Tuesday, causing a lower launch speed than expected. So that was the claim. And so what students had to do is they use this modeling tool to draw the magnetic field lines, what they look like when they're aligned and when they're misaligned. And so this is what it looks like when they're aligned. This looks like when they're misaligned. So when they're misaligned, there's one north-south magnetic field line that goes from north of the launcher magnet to the south of the spacecraft magnet, whereas if they're aligned, the north-south magnetic field lines go from north to south within the same magnet. They don't cross over at all. So this is a case where it's all repulsion. This is a case where we have repulsion here and here, but we have attraction here. So that might have caused a lower launch speed than expected. But here's the actual data from the Universal Space Agency, and it shows that Tuesday, no, the magnetic field, the magnets weren't misaligned. The launch magnet and the spacecraft magnet were not misaligned, so we have all repulsion. There's no crossover of magnetic field lines from one magnet to the other. So what students had to do is they had to provide evidence that goes against the claim. They had to refute the claim that the magnets were misaligned, causing a lower than expected launch speed. So students did that. They had to turn in, this is 10 points, and the next day they did a paragraph self-check revision. So this is what I'm looking for grading their assignment, to see if they have this information in there. So they had an opportunity to revise it, and then I graded it. And then what we did the next day is I showed them a sample, or not the next, yeah, the next day, that would be Friday, a sample paragraph of the paragraph, what it looks like for a 10-point grade or credit, and this is what it looks like. All right, so then on Thursday we did a lesson 2.1, kind of introduction to a new topic, and they added some information to the reference notebook. So the reference notebook, let's take a look at the reference notebook. So from here they go to a link to the reference notebook. So they have all their questions for each chapter, they have the key concepts for each chapter, and then they also have the vocabulary words. So we're up to kinetic energy for the vocabulary terms. Also on Friday, we did an Edpuzzle, can humans sense magnetic fields? It looks like this.
They're roughly the strength of Earth's magnetic field, and we'll see if my brain is picking up on the fact that the magnetic field is changing.
So based on what they just saw in that clip, they had to answer that question. And then we did an Amplify Chapter 1 review competition. So that's what we did this week. Hope you have a good weekend. Bye-bye.